Hello everyone, welcome back to my channel. I am Sakshi and here is the 10th episode of Learn DSA with Sakshi. So far in this linked list series, we have covered some really important types of linked list in C. We started with the singly linear linked list, then move on to the doubly linear linked list, and after that we understood how singly circular linked list works. So in today's video, we'll take this one more step further and explore the doubly circular linked list in C. We understand its structure, operation, and how it works internally. And after that, we'll do something really interesting. We'll take the traditionally singly linear linked list program in C and then convert it step by step into a C++ program using the object-oriented programming. This will help you clearly understand how to transition from procedural C code to modern CPP class-based code. So this will be very interesting. Don't miss it. So grab your notebook and let's get started. So we'll divide this video in two parts. In the first part, we'll cover what is doubly circular linked list, how it works, and see its code. And then in the second part of this video, we'll understood the CPP program. So let's start with the first one. So what is doubly circular linked list? Doubly circular linked list is a type of linked list where each node has two pointers, one to the next node and the other to the previous node. And it is circular in both directions, meaning that the last node connects to the first and the first connects back to the last. Here I give you the diagram. So, so you will get a clear idea about it. So let's say we have 3 to 4 nodes in our linked list. For the time being, let's assume that our linked list is consist of the 3 nodes. So I'm drawing the 3 nodes here. As it is the doubly circular linked list, so the arrow will be like this and it is circular. So the last node will connect to the first edge. So I'm just drawing this. So in this way, it is circularly connected to the first node, but it is doubly circular, means that this is also connected to the first node, is also connected to the last node. So this is connected in this way. So it forms a circle like this, and it is doubly means it is circular in both the directions. I hope you understand it. Now let's see the theory of the doubly circular linked list. As I said, every node contains the three fields, that is the data, next, and the previous. Why previous? Because it is a doubly linked list. Then the next pointer points to the next node, and the previous pointer points to the previous node. As earlier in the doubly linear linked list. And it is circular, means tails next equal to head. If you can see here, this is tail, striking it here, and this is head, edge. Okay, so tails next is connected to the head, and then head previous equal to tail. Head previous equal to tail. Let's correct it. It has three nodes, right? One is for the data, second is for the next, and third one is for the previous. So heads previous equal to tail. So this is how the doubly circular linked list is. Then after we complete the doubly circular linked list code, we'll see all the 8 types of function, just like we saw in the previous linked list. So just open your VS Code. So here is our VS Code. Friends, in the last video, it got a bit too lengthy because I explained everything in detail, each function, and I draw the diagram where required. So in today's video, I'm keeping it short and simple. I'll directly show you the code first. You can pause the video, read through it, and you can type it. Then I'll start explaining each function one by one with the complete logic. So till now we have seen up to program 14, and this is the last program. So program 15 is the program of the doubly circular linked list. So firstly, I'll show you the entire code, and then you can just pause the video and type it, and then I'll explain to you. So I'm just zooming it. So for zooming, Control plus. Now here is the complete code of the doubly circular linked list. We'll see its 8 function one by one with the complete logic. Actually, the logic is almost same. Just we need to play with its pointer, means how it is connected to each other, what links are there and what not. Only this part. If you can understand or you understood the just once a linear, let's say singly linear linked list, then every program is just a upgradation of the previous one. So here are the 8 functions, and from the main function, we just call that function. So you can pause and write the video. Now let's start with the explanation of the doubly circular linked list. Now just break down the code, each line of the code so that you can understand it completely. So starting with the header file, include the header files in your code, then write the type def structure here. If you are watching the previous or watch the previous programs of the linked list with full of attention, then here you will see a change here. Something is different here. Right. Here we combine the structure node and the type def into this part. Right. If you can see in the program 11, we wrote the node structure differently and type def completely different. Right. But in this program, we combine it. So how to combine and write it? Firstly, write the type def, then the structure node, and then define the its members. As it is the doubly circular linked list, so there are 3 members of the node. First is the data, then second is the structure node and structure node next, and third is the structure node star previous. Right. So this is the building block of our linked list. Data store the value next point toward the next node in the list, and the previous points to the previous node in the linked list. And p node as a pointer to a node, and whereas pp node is a pointer to a pointer node used for modifying head and tail in the list. So this is about the type def structure, combined structure. Now let's see the insert first function. It is just like the similar previous functions. Firstly, we define its parameter as pp node head, then tail and number. Why tail? Because it is a circular linked list. So that's why we include tail here. Then we take one new node and initialize it to 0, and then allocating memory to it by using the malloc, and then assign data to it, that is the number, initialize next and previous to null. The function insert first inserts a node at the beginning. Right. Now here we handle the cases. Means if the list is empty, here is the first case. If the list is empty or not. If it is empty, then what to do? And if not, then what to do? If the list is empty, how to check the list is whether it's empty or not? Just a single and simple statement here. We need to check both condition. Why? Because it is a doubly linked list. So we need to check its head and tail part also. If head is null and similarly, if tail is also null, then we can say that our linked list is empty. And when both are empty means when both point to the null, then head and tail both point to the new node. Means make star head equal to new n and then star tail equal to new n. It means both head and tail both point to the new node. Otherwise means if it is not empty, then new node points to the old node. So this is new node. And our old node is the head, so it points to the star head, right? So new and next is equal to head. Then old head's pointer points back to the new node. This is old's previous pointer points back to the new node. And then we updated the head here, right? In this video, this is of the singly circular linked list. Here we just update the head. right? If you can observe here, new and next equal to star head. We took this statement same as it is in the program number 15, and just we add one more line, means that's a connection to the previous node, and that is star head previous equal to new node. So maintaining the circularity, and then tell next equal to star head, right? So then we update the head pointer, and now here is the interesting part. Tells next means the last node next is connected to the star head, which is the first node. Similarly, star head previous means the first head previous is connected to the last node star head. We maintain circularity from both the sides because it is the doubly and then circular like this. So that's it. Just two changes here. First is this line and second is the this, and that's all. Rest of the program remains as it is. So this is how insert first. Then let's move toward the insert last function. Similarly, it will take the parameters same as the insert first, that is the pp node head, then tail and int number. Similarly, here we create one new node. So here also we are taking one new node, initialize it to null, then allocating memory to it by using the mallocs, then assigning data. That is the number which we want to assign. Means if I want to insert 11 at node, then 11 will be the number. Then next and previous initialize it to null. Then again we are checking if the list is empty or not. If the list is empty, how to check? By this condition. I just told it, right? And if it is empty, make the star head and star tail both pointing to the new node. And if the list is not empty, then just insert last, means we have to insert at the last. So if list is not empty, then make the current tails next is equal to new node. So tail is the last node, tails next equal to new node. We are making tail next equal to new node, and then new node previous is equal to tail. So we are both connecting in forward direction and then in backward direction, and then making star tail equal to new n. And at the end, we are maintaining circularity. That is star tail equal next equal to head and head previous equal to tail. So this is about the insert last function. It is just like the similar one we saw in the previous videos, and it is just like the revision of those programs because everything is same. This logic, everything is same. We are just making some few changes and then connect to the nodes. Now let's see the delete first. Delete first means it delete the first node. So as we have to delete it, there will be only two parameters. First is the pp node head and then pp node tail. There is no need of the number because it is already present in the list, so we don't require it. Now we are checking it if in delete function we need to check the three conditions. Those three conditions are: first is if the list is empty or not. If it is not empty, then check whether it's contain a single node or not. And if it is both the condition are wrong, then third one will be the it contains the multiple node. Then how to delete the nodes in these three cases. So first, if it is empty, if the list is empty, just simply reform it because there is no node, so no need to delete it, right? Then if the list is, means if it is it has only one node, then just free the head and free and reset it. It's like free and then reset it. Means if it has only one node, then it head and tail will be the same, right? So we are just freeing star head, then making star head and star tail, means we simply delete it. Then else part. If the list has multiple nodes, sorry, this communities. Okay. So otherwise, update the head as head equal to head next, right? Then free tails next, and tail next equal to star head and star head equal to tail next. It means we first move tail backward, then free the old tail, and then reconnect tail to the head. And just draw one diagram and show how it works to you. So here is the diagram I drawn for you. So here are the three nodes. Let's say first this is head and last one is the tail. So whatever program says, first is the star head equal to star head next. So firstly, star head means this point to this. Right now it's point to star head next. What is star head next? This part. So it means this is gone. This has no connection with the this first node. Then it says free tells next. So this is tells next is this part. So free. So just remove it. Then tells next equal to star head. Tells next equal to star head. Now our star head is this. Right. Now this makes connection to now this is deleted and this makes connection just like this. Okay. And at the end, make star head previous equal to star tail. Star head is this. Its previous is star tail. So just making its previous is star tail means in this way it is connected and it just the first node is simply get deleted from here and it is how link and unlink part works here. So it's all about the delete first. Now let's quickly see the delete last. Again the same thing for the delete last. Its parameter to denote head and tail, no need of integer number. Then as it is a delete function, we are checking the three conditions. First is if the list is empty or not, if it is contain single node or multiple node. If it is empty, just simply return format. And if it's contain one node, just free that node and make star head and tail which points to the same node, make it null. So it's simply remove that node. And in the else part, star tail equal to star tail previous. So make this connection first, then free that tells next which is pointed to the star head. So we just simply remove it. Then makes star tail next equal to star head and previous to star tail. Let's see its diagram quickly. I just stop this video and once I draw the diagram, I'll explain to you. So this is our basic doubly circular linked list. Now we need to delete the last node. So how to delete it? First make star tail equal to star tail previous. Now here star tail is equal to star tails. 1 second. Star tail equal to tail previous. So this is our star tail. So now it is this. We are just updating our tail. Now this is firstly this is our tail. Now this is our tail. Then free tails next. Now this is our tail. So its next is this node. So just free it. So just free it next. Then tails next is equal to star head. Now tails next is as it is removed. This is removed. Tails next. So this is tails next. This is how it is connected. Tails next equal to star head, right? It links like this. Then star head previous equal to star tail. So this is star head and its previous is connected to star tail. So in this way, this will also unlink from that, and in this way, this will get deleted. So this is how. So this is how we can delete the last node of the linked list. Once you understand the code, just make sure you practice of the diagrams. From the diagrams, you will understand it much more clearer and better. And then you don't require to mug up the code and all. If you once understand how it works from the diagram. So for better understanding, draw the diagrams simultaneously. Now let's see the display part. Display and count is same. So in display, we are taking only p node, head and tail as it is the call by value function. So if the list is empty, then we are printing linked list is empty and returning from it. No elements, so no need to display. And if list is not empty, then we first print the statement elements of linked list are and then we print the statement. So here in circular linked list, I said in the previous video, we use the do while loop instead of the while loop. So this is for the printing part. What we are printing the heads data. And then we are updating head to head next. And we are printing it whenever head is not equal to tails next. Means when tails next is equal to head, it means that we reach all the positions of the linked list and we print it. And at the end, printf and then it will come back to the new line. So display logic is same. Then the count logic. Now let's see the count function. So this counts the nodes in the linked list. So starting from the head, then it will increment the counter while moving through the list and it will stop when you reach the head again. So this is if it is empty, return from it. If it is not empty, then from the do while loop, we reach to the reach the head again and then we'll start when we stop when we reach the head again and then return the count. So this is how count function works. The same as the previous one. No new logic here. Now just understand how insert add position will work in the W circular linked list. So this part is same that taking I count, then I pointer, I variable, then two new nodes initializing it to null, then taking I count and count the call the count function and just we add the tail parameter here, right? And then checking the condition is valid or not. So if it is less than one or if it is let's say more than the count nodes, then the position is invalid. Then if position is 1, it means you have to insert at the first position. So call the insert first function. And if the position is the last, means I count plus 1, then you have to insert at the last. So call the insert last function. And if you want to insert anywhere in between the nodes, then call just implement the else logic. What this logic said, first make a new node, allocating memory data, then next and previous to it. Then take a temporary pointer, then holds the address of the first node and from the for loop, we reach to the position where we want to insert that node. So I pose -1. And then at the same time, we are incrementing our temp pointer. So if first temp is 100, then 200, then 300, and then 400, let's say 400. So in this way, we reach to our desired position. And then here is the actual logic, just 4 lines. In this, the 2 lines are same. This line and this line is same from the singly program. And just these two are new. So what it said, I'll just draw a diagram. So this is the diagram. Let's say I have to insert the node whose address is 250. So, and my temp is now pointing to 200. So our code says that new and next equal to temp next. So our new n is this. So new and next is this. This is next and this is previous. So new and next is equal to temp next. Temp is this, temp next is this. So connection will like this, right? And then temps next previous. This is temps next is this, and temps next previous is this. Just 1 second. What it says that temps next previous. So this is temps next, and temps next is this. Temps next previous pointed to new n, and then temps next is equal to new n. Third line. Temp next is pointed to new n. Similarly, new and previous is equal to temp. So this is new and its previous this, and it is pointed to temp. So in this way, this will remove, and this will be our flow from this 100, 200, then 250, and then 300, and then again 100. So this is how our insert at position works. Now let's quickly look at the delete at position. So this is the last function of our doubly circular linked list. So the last function of the doubly circular linked list is delete at position. Again, it will take the same parameter as the insert position. Everything is same. We take 2 pointers. One is the temporary, then second is the target. So if the position, if it is checking condition, position is valid or not, then if the condition is first, then simply delete the first, call delete first. If position is last, call delete last. And if it is not, then implement this logic. Firstly, holding the address of the first node, then reach to our desired position and simultaneously increment our temp pointer. And then these 4 lines. Now let's quickly draw its diagram. So here is the diagram for the delete at position function. And let's say I want to delete the node which is at the position 3. So I want to delete this node. So how to delete it? Let's say my temporary pointer is this and then target is this. Now let's quickly understand its logic. Firstly, it says that target equal to temp next. So target is this and which is equal to temp next. So this is right. And then temps next equal to target next. Now temps next, this is next, right? Temps next equal to target next. Target next is this, right? So now the link will be like this. And target next previous equal to temp. So targets, this is next, previous. So target next previous is like this. So in this way, we delete both the link which connect them to old target and now free the target and now just free it means delete it and our new arrow will be look like just one second. I will make it bold. So this is how our new arrow will be. And then at the end you free that note. So these are the simple links between the new statements and in this way we delete the certain specific position which we want to delete. So in this way we complete the delete at position function also. Now it's time for implementation. In from the main function I just call the insert first for 3 times, similarly insert last for the 3 times, then display the list. Then I insert 75 at the fourth position, then take count of it and display. Similarly, at the end, I am deleting the fourth position, no, and then display and delete it. Now just look at the output of this program. Just save your program and open your command prompt. Then go to your specific folder directory. Then type GCC, your program number, .c, then you must do my exe, then my exe.exe and enter. So our code is working fine. So here is the first part. Firstly, we are call insert first and insert last 3 times. So total number of elements are 7. In the second part, we are adding 75 at the fourth position. So first, second, third, and fourth. So this is also right. And count are 7 now. Now our updated linked list is this. Now we want to insert that 75 from the fourth position. So first, second, third, fourth. So 75 is successfully deleted from the list and the count is decreased to 6. So this is working. This is the working code of the doubly circular linked list. So in this way, we completed the doubly circular linked list also. So this is the end of our linked list. We saw all types of linked list. If you can remember in the starting videos, I told you that we are going to learn the 4 types of linked list. Firstly, say the linear, then circular. In linear, there are 2 parts and circular also 2 parts, means total 4. So firstly, we saw the singly linear linked list, then doubly linear linked list. Then we saw singly circular and now we are saying, and this is the doubly circular. So we completed all 4 types of linked list in C with the same logic, simple understanding of the code, and with some hands-on implementation and diagram. So this is all about the linked list. Now just look at the difference between the all types of linked list. Just a quick summary of it. So here is the comparison table of the all 4 types of the linked list. So first feature is the forward traversal. We can travel forward in all 4 types of linked lists, right? But we cannot travel back in all the 4 types of linked lists. We just travel back in only doubly linked list, that is doubly linear, whether it is linear or circular. Like just it should be doubly for backward traversal. Then third feature is the circular nature. So singly circular and doubly circular have the circular nature, as the name says itself. Then last node next. If you can remember, in singly linear and doubly linear means in linear linked list, last node is null. And in circular linked list, last node is head means tail is connected to head. So in this way, last node is connected to head. And head's previous. So previous is for the doubly part. So previous is null in the doubly linked list in linear and circular also. And now here is the most important part, application of each type of linked list. So we use the singly linear linked list in simple stack, right? And we use doubly linear linked list in browser history, then singly circular in the round robin task, and then doubly circular linked list in the playlist, then TP cache and all. So this is all about the linked list. All right, friends, we have completed the most important and often the most confusing part of the data structure, that is the linked list. We covered all its 4 types with the hands-on implementation. So now it's time to take one step further and see how we can write the same logic using the C++ and object-oriented programming. So let's start with the second part of the video. Now let's understand how we can transit the C code to CPP, that is the programming procedural programming. Oops. Um, Before starting, let's take a pause and understand why we are doing all this, means why we need to transition from C to C++. Because in C language, everything revolves around the functions and pointers, right? There is no structure to group data and function together. So this is the drawback, and its advantage is in the CPP. So here comes the CPP. In CPP, we have a powerful concept called the classes. It's like a box where we can keep both the data and functions together. So instead of writing all the functions separately, then passing the pointers every time, it is a hectic task, and it takes means it may be confusing sometimes. So in CPP, we now keep everything inside a class. So that's why we are converting our C program to CPP program. Think of a class as a toolbox, and inside this toolbox, you have head. That is our starting node. Then we can also keep the icons, which keep the tracks of how many nodes we have, and then the functions like the insert code, delete, class, display are the tools we use to work with the list. So this is all about the CPP. That is oops. Why we are using oops if we have C or B. So without wasting time, let's start with the CPP program. Here I wrote the basic code, or let's say the structure of our singly linear linked list. Okay. Firstly, we'll see the singly linear linked list, and then you can do the remaining at your own. So it is very simple. So let's start with this. So firstly, include this header file. Now this is IO stream, and in C we include the header file as stdio standard input out. This is the same library. It is for the standard input and output, but it's from the CPP library. Then using namespace std means when we are using this, in CPP we don't need to write std then colon colon then print your statement or whenever whatever you want to print it. So for simplification, we are using namespace std here. Then struct node. This is same as our previous C program where we declared members, that is the integer data, then struct node next pointer. And as we are going to learn the singly linear linked list, so we are using only one pointer here. Now type def structure is also same, no need to change. Now here comes the important part or the heroic part, let's say. In C program, we need to write the code for the each function separately, right? But in CPP, we declare one class, and within the same class, we write all the programs. So firstly, we declare one class. So this class is up to this. At the end of the class, don't forget to add semicolon. So this will be the end of our class. And in the end class, we write all our programs together. So pnode head. Pnode head is means it requires in all the functions. So it is we are taking it as public here. Then it is the constructor. What is this? I am explaining to you later. And these are the 8 functions, right? So I'm just writing its basic structure here and its parameter here, and then simply creating the object of the class and then calling from it. So this is how the basic structure of the CPP program. Whenever you write the programs of the linked list in C++, make sure to write in this type so that you will get it and understand it properly. And it is very simple. First include header file, then add the structure node, then type def, then define the class. In that define what is public and then call its constructor, and then define all your functions first, list of function, then passing a parameter to it and simply creating the object of the class. Now this is the basic program, and here is the actual program of the single linear linked list in C++. Here I write every function in detail. So let's start with it. So I think here is the most common part. Everyone will understand it. So now let's start with the class definition. So this is class singly LL, right? So in C we use a pointer to pointer for managing the head, right? We use pp head, pp node head, right? But in C++ we make head a data member inside the class. It is the member of the class. So we are making p node head member of the class inside the class, and we initialize it in the constructor. This is the oops way of encapsulating everything inside the class. What is encapsulation and all? It is the parts of the object-oriented programming. So encapsulation is basically wrapping up the code or sensitive data. So we are initializing it in the constructor and initialize it to null. And similarly, I take one variable that is icon, which is required in every part of the code. And similarly, I'm initializing it to 0 in the constructor part. Then now let's see the insert first. So this function insert a new node at the beginning, just like in C, but instead of the malloc, we use new in C++ for the memory allocation. So C we use previously we used pnode what pnode new n. We use this much of line, this lengthy line, but here is simply with the new. We are allocating memory. Then its data and next pointer is same. Now it's if you can see here, we include only mm, int number because in previous we include the pp node head, but we are taking it here and it is publicly, so no need to write in every program, sorry, every function. So and also we don't need the pp node now since head is already the part of our class. Then if head equal to node, so we are not using pointer here. So we are checking the condition. If head is null, then make the head is equal to new n, and else then manage its links and then increment the counter. So logic is same, just how we define how to write this its structure is different, and this only this much structure is different. This line rather than this only this line. So insert last is also same. We define two variable new and null, then assign memory to the new n by the new, then simply check the condition. If it is not null, then make it as the temporary pointer, then hide, and simply logic is same. Then insert position is also same. First checking it is the filter means position is valid or not. If it is one, call insert first. If the position is last, call insert last. And if it is not, make new variable, assigning no data next to it. Everything is same. No need to update the logic, just need to add the follow the CPP style. Same logic for insert add position, then delete first. Again, the same logic, everything is same. Just we use free in C programming. Here we use delete. Just simply delete. And while deleting, we are making our counter, decrement the counter. And while adding means inserting, we are incrementing our counter. We are manually handling our count function. So when delete last, again same logic, just use delete instead of free and decrement the counter. Again same logic for the delete at position, filter, then first position or last or else part and deleting. Now the display part, in display part, first we make a temporary variable pointer and point it to the head, means starting from the head. And if the list is empty, means while the list is not empty, as it is a singly linked list, and its end means null node. So whenever means while temp is not equal to null, print. How we print in CPP? We use cout and this operator, right? We have to print the temp data, and then we are incrementing, just simply incrementing the temp, right? And then at the end print null, and we are simply from here we are returning the count. So this is the code of the singly linear linked list in CPP. Very simple now. Now in the main part of the program, we are making one object of the class. Then we are taking one variable and initialize it to 0. We need this variable for the count function. So now how to call the object as obj, and then insert first, calling our first insert first program, then calling our insert last program. Similarly, now we add the means firstly we are inserting 75 at the fourth position, and then we are taking count of it and then display it. Similarly, after displaying, we are deleting the fourth position element and then count of it and displaying the list again. So now just save how to compile and run this program. Just go to your command prompt. Now in C program, while running it, we use GCC, but now instead of GCC, we use G++. And our program extension is CPP, not C. So program 17.cpp, then my exe only. Actually, I forget to write the O minus, then my exe.exe. So here is our linked list. So this is the first part. 11, 21, 51, 75, 101, 111, 21, 121, and the number of elements are 7. We are inserting, we insert 75 at the fourth position. And in the next part, we remove the element of the fourth position, that is 75. So 75 is removed from the C and count is decreasing to 6. See, its logic is same. Its output is also same. Only we just follow the CPP style and nothing else. And it is as simple as that of the C program. So this is how we covered the both C and CPP program. All right. With this, we have officially completed all types of linked lists. Singly linear, then doubly linear, singly circular, and doubly circular. And we have even seen how to implement singly linear linked list in C++ using the classes. I hope now you will be able to try converting remaining linked list programs into C++ on your own. Yes, it took us a lot of time to finish the entire linked list topic, but that's because we were building a strong foundation. If you have been following along, you might have noticed one thing, that every program follows a simple and consistent structure, which makes it easier to understand and remember. So that's a wrap up for the linked list. Now in the next video, we will move ahead to the next important data structure, that is the stack and queue. So that's all for today. Thanks for watching and keep practicing. Thank you.